If you can bend time, can you tear history? Kind of, but not in the way that you might think. I'm Charlie, I got a physics degree, and I want to explain this equation that I think less than 1% of the world understands, even though you can find it in like high school physics textbooks. Page 805 of mine, if you're wondering. If you've seen Interstellar, then you kind of already get this. You know in that movie that depending on how close you are to a really big object like a black hole, time can pass for you at different rates. That is real physics that comes out of general relativity, which is a like offshoot of this original discovery of the Einstein's theory of special relativity. Time bends. I'm going to explain what that means, but I want to return to our original question, which is, if you can bend time, can you tear history? Let's talk about it. A question that might be helpful to you is, what would it even mean for time to move at different rates? Like, doesn't time move at the rate of time? That's what this delta t and this delta t prime is trying to delineate. The amount of time that passes for you versus the amount of time that passes for me. In the interstellar case, being close to a massive object can dilate time, but in the special relativity case, just moving relative to someone can also dilate time. And it has a very peculiar implication for history, and it's this. For purposes of this example, we're going to say that I live on another planet in pink time, and you live on Earth in yellow time. When you are used to thinking of time as linear, you think of events happening in sequential order. I get fired from my job on this other planet, someone I know gets cancer, and then my dog dies. This isn't supposed to be autobiographical. We'll refer to the cancer as event B, and because we're dealing with two different timelines, we'll call this B prime versus B. The problem is that if time travels at different rates for different people, then events that appear to be in one order for one person can be stretched or dilated to the perspective of another person. It's actually going to get kind of confusing if we use the same events on both different planets. So for purposes of this example, we're going to have the sad timeline for me on my planet and a happier timeline where you get promoted and then you get married and then you buy a house. I only have so much time to make this video, so I'm gonna have to skip a couple of logical steps here, but it does check out. We've known this since the early 1900s when Einstein discovered it. If you can pinch and squeeze time so that it travels at different rates for different frames of reference, then we might look at each other and see the cancer and the marriage as happening at the same time, but not everyone in the universe is going to agree that these things were simultaneous. If the rate of passage of time can change depending on your frame of reference, then the concept of now kind of breaks down in the larger universe. Under certain conditions, now means different things to different people. I've skipped some details, but this is called the relativity of simultaneity, and it's a core tenet of special relativity, a theory that is well established in our understanding of time. Said slightly differently, the bendiness of time implies the relativity of simultaneity, the idea that different observers in the universe can see different events in history taking place in different orders, and both sets of people are right in terms of physics. So to return to our original question, if you can bend time, which you can, under certain conditions, can you tear history? Kind of. But there's a catch, and in physics, there's always a catch. There is a concept in physics called space-like, time-like, and light-like space-time vectors. I know that was word salad. I can't all the way explain it in this video, and I have to thank Jenan Ismail, a philosopher of physics, who explained this to me at a philosophy of physics event at Rutgers in 2018, because you really helped me understand the intuitions around this. But let me summarize it in terms of tearing history and what this means. In order to tear history, which I mean change the order in which events in history occur, you have to have a space-like space-time vector, aka this term v has to be really big. To see this effect of relativistic time dilation, you have to move really, really fast compared to the other frame of reference that you are comparing yourself to. And I'm skipping some steps here again, but in order to move really fast relative to someone, you have to be wicked far away from that person. In a sense, you are trading time for space. Part of why we call it space-time is because of this property that they are connected to one another. And here is where we get the catchiest of catches, the payoff for all these different ways of perceiving time and space. In understanding these concepts, it can begin to feel like reality is just a matter of perception, a mantra of the post-truth, political postmodernism that we seem to live in. But this is not actually the case. The relativity of simultaneity requires a distance and speed between us that is not physically the case. It can feel, with the amount of division in the world, with the amount of space between us, that we have torn history into. We have not even according to the wibbly-wobbly, timey-wimey theory that allows us physically to bend time. Put more simply, it feels like we live in two different realities, but we do not. We are not far enough away from each other in terms of physics, or moving fast enough relative to each other in terms of physics for us to be in two different worlds. There is, in fact, only this one. The technology of the telescope allowed us to see for the first time that we were not the center of the universe, that despite what it looked like, everything did not revolve around us. We went from believing that we were the center of the universe to believing that there is no center of the universe, from believing that there is only one objective time to believing that time, in some senses, can be a matter of perspective. If this v means the speed at which we are moving relative to each other, something interesting happens when you tell the math that we live on the same planet. If you tell the physics, we actually live on the same planet, the physics says, hey, you live in the same timeline, in the same history, and in the same reality. And I don't know about you, but I find that oddly reassuring. I'm Charlie. This is That Makes Sense to Me. Obligatory influence, things like share, subscribe, follow, Patreon, book list, and bio. Thanks for listening, and happy reading.